So now that we have our geometry and we have our excitations defined, we're going to move on to analysis setup. This is different than the solution type. If I right click on the analysis node, it's going to say add solution setup. I'm going to choose that, and I'm only going to make probably a few changes here. I'm going to leave that name as the default. I'll describe maximum passes either during the solution or after the solution. I'm going to change this to, let's just say, I'm going to make it a pretty high number for now. I'm going to make it 30. And I'm going to change the percent error from 1 to 0.1. And we'll see if that works for now. And I'm going to leave everything else the same. In future iterations of this lesson or exercise, we might get into more of these settings in the other tabs. But for now, let's just go with these settings, and maybe you can remember that percentage error. This will be important as we watch the solution take place. So I'm going to say OK, and now I should be able to go to the simulation tab. It's a good habit to go ahead and hit the big green check mark that says validate, and I expect to see all these parts of the workflow show up as green check mark, indicating that there's nothing that we forgot to do. So I'm going to close that out. One last thing that's worth checking before you move on is if you go to HPC options, usually the default will be the one configuration that you have. I'm going to go to the edit button just to verify that the number of cores is what you expect it to be. It really depends on the system that you're working on. If you're on a shared server, you might have to negotiate with the other users how many cores you're using. My Dell laptop that I'm using for this training has 8 cores. I'm going to go ahead and use all of them. So this could be very important to speed up the solution and make sure that you're at least not hardwired or default set to 1 core. So using multiple cores is always beneficial. I didn't change anything, so I'm just going to cancel out of there. And again, the validation already took place. I'm going to go ahead and hit. I can either hit Analyze All. It's safe to do here. Sometimes it could be a better practice as you start to build up models with multiple setups. Sometimes it's a better practice to only right-click the setup that you're interested in solving. This will make more sense later. So either way, I'm going to go ahead and choose Analyze, or you could have hit the Analyze All button. And when I do that, you'll notice the first thing it's going to ask me to save. I haven't saved this project yet. This is going to default to a directory that was set up during the installation. I know where to find this model. I'm just going to go ahead and leave it as project 1 for now, and I'll say save. I know how to get back to that. And you should see, if you have the progress window open and the message manager window open, you should see it go through something called the adaptive pass process. And I'm going to explain that as probably when the solution is complete and we look at maybe the results along with the mesh and some other terms that you haven't really been introduced to yet. So we'll let this go. This might take a couple minutes depending on your compute resources. So I'll go ahead and pause the video and come back when done. So after a pretty short period of time, just maybe less than a couple of minutes, I have what looks like a completed solution. Nothing left in the progress bar here. As I go to the message manager, though, I can expand this down, and I should see I get something like a normal completion. If there were any errors, they would have shown up. The next thing I wanted to do, though, was actually let's get a little bit more information on the result. I switched to the Results tab. The first thing I want to do is go to Solution Data. So when I hit that button, I get a lot of information. I'm probably not going to go through all of the tabs in detail here, but one thing that is always important is to look at whether or not I have a valid result. I should always see numbers present here. I'm on the Convergence tab. When I go to plot mode, and I'm going to leave the x-axis to pass, and I'm going to look at delta energy. I'm probably going to talk more about this as we go into maybe the more intermediate or advanced sessions, but I think the best way to interpret this is that when we actually define that setup, we quickly made a couple of changes to the number of adaptive passes allowed and the convergence criteria. We changed it from 1% to 0.1%. And when the solution is taking place, there's a process where it will run subsequent simulations and compare the result to the previous result, and those are called the passes. And as long as that subsequent solution still has measurable amount of error, which is above the number that we had specified, in our case 0.1%, it's going to make some adjustments and resolve that problem until it meets that criteria. So what this tells us is that it started out and it took a number of passes and actually was going in the wrong direction for a while until the error started to improve among subsequent passes. And by the time we got out here to the 11th pass, it actually met the criteria where the error between the current solution on the 11th pass was reduced down to less than 0.1% of error. So this convergence information that we have here is actually a very critical metric in our numerical or our computational simulations, and you'll see us come back to this time and time again. Another thing worth showing here, I have not introduced the idea of tetrahedra or mesh in really any detail yet, but notice this number of tetrahedra is increasing with the passes. So as the result gets better from a convergence standpoint, you'll find that the number of these elements called tetrahedra are actually increasing, which also makes sense. The tetrahedra is tied directly to the mesh. It's actually part of the mesh. I can click this tab over here and look at mesh statistics. Again, we haven't talked about this in detail yet, but we're going to, so I want you to be aware of where to find this. Another thing worth looking at here is on the profile tab. I'm going to go ahead and expand the view so that we can see more information here. Sometimes this can really help troubleshoot problems or just your simulation in general, so you get a better understanding of what's going on. You typically get a big record of all the time steps that are taking place in here. I should say time stamps, as it goes through different parts of the solution process. It'll let you know what machine you're solving on, let you know what some of your settings were. Here's this term tetrahedra again. We'll talk about that soon enough, but you'll see it'll show memory usage and all these important things that you might want to know. And of course, you always want to end up seeing something like a completed solution process that has normal completion at the end.